So this is meant to be a audio recording of um, a research essay or a research or an essay or concept or theory that I've developed. Um, and the purpose of this recording is to help, um, um, I guess, protect my intellectual property. But further, I think just to sort of put my ideas in some sort of framework in which I can communicate it immediately whilst I write the paper. So if you're listening, and so far it's drabby and uninteresting, stay tuned because it's sure to get interesting. Um, or at least I hope it might be interesting to you. I can't guarantee that. Okay, so if anyone has any understanding of systems theory or systems philosophy, and you'll see in the caption that my theory is a theoretical model of collecting data via artificial intelligence through the properties that we describe the world to be, through each of its properties, so that we gap the subject-object theories of existence. So what that means is, if we look at systems theory or general systems theory, the aim is to gap or to found a foundation on which all science or science of creation and existence come to be, from physics, deterministic, physicalistic, even mysteriousism, like spirituality, say, a religious construction of existence, meta, everything. And we're also talking, if you're familiar and you understand this, is epistemology, which is what is knowledge? What is the grounding for knowledge? And there is a whole load of different theories, from coherence theory to founderance theory, and a lot of this started in that realm and sent me off in that direction. To framework how this works is that the artificial intelligence is collecting the data, and to quickly sum it up is that each property is considered a tag and designated a specific binary code. That binary code belongs only to that single property. When that property slightly changes, 1, 0, or 1 is added to the binary code, or perhaps a fuzzy logic in fuzzy code, fuzzy logic, I think it's a 0 and 1 at the same time, depending on what category or how that property is changed relative to the other properties. So I don't want to make this too complicated yet. But so what we're then doing is describing the things how they are through their properties. What that then reveals, and we can relate that to systems theory, is the interconnected nature that is not available to us via mechanistic fragmented ways of collecting and analyzing data. The key here being the interconnectedness. See, blue being a form of color is not universal, yet is close to a universal. Of course, blue being only applicable to the things that are blue, but unfortunately blue being a color among other colors does not quite qualify it as a universal, but a base, and I'll get into that later. And so why I mention that is that blue, in its mechanistic form, either say from the subject or object, is only viewed as blue. When we collect data and we say something is a blue car, we don't represent how that blue really is interconnected in the world. We just simply analyze that data and basically copy paste the thing without it seeing what it really is. Because what it really is a part of this interconnected systems, multiple systems of things. to construct an idea of how systems theory comes into the mind, I would say, at least for me, in my searching, which came through an organic process, led to systems theory, was the idea that all is one. And that is debatable. But for me, from my perspective, all is one is quite simply and utterly truth. And it's not just truth, it's just as is. And because it's just as is, and I'll expand on that so maybe you can understand where I'm going with this thought. All is one is the idea that something cannot come from nothing, Parmenidean law. And because something cannot come from nothing, all something, even with negation, the nothingness, is a part of one whole something that is somewhere, that is one. Even if it's infinitely digressive and infinitely growing, progressive, then it wouldn't change the facticity of being that this system of infinity is in one finite thing. What grows out of that thought is the idea that if everything is one, then not only is everything one, but everything is one interconnected thing. And I'm not sure that's how systems theory came to be. But certainly for me, it's what led me to finding systems theory. Through systems theory, we understand that everything is a part of a system. So when you drive a car, your car and that relationship is a system. The car in and of itself is within a system that belongs to what is a car, belongs to what the car uses. So the oil, the plastics, the metals that make up the car, the actual materials belong to systems of that material that is then a part of a greater system of, say, oil, belonging to the system of oil and how that came to be. And we can really continue to grow that. And you can see how that's almost infinite in the mind, and it continues, but it's not. Unfortunately, because it has that overwhelming feeling, the mind, the human is so, we have a gap in the ability to form that type of thinking. So how do we close that gap and make this more affective? Find a way to do exactly that. Well, the resolve or the solution is this model, or I believe it's this model, which would be an artificial intelligence that would collect the data in a very specific way via its properties, broken down through binary tags that then reveal its interconnectedness. What we're also doing is creating systemic properties or systemic codes that also exist at the same time. So you have multi-layered coding and binary tags that then belong to a specific property. When we have this binary theory revealed and we begin to work it, we can slowly use it. And the issue being, where do we get the data? This question came to me and really stumbled me because it actually is a big deal. How do we collect this mass data that is the world? Well, I don't think that it's maybe possible, but I do think that if we concentrate this theory and this program, if created, and with some effort I will try, I think that we can begin to start to use it. We can begin to build the greater program. I think that things will change so fast and it will evolve so quickly that I maybe underestimate it. But say that statement is an overestimation. That's fine. I think that we slowly apply it to specific areas, and we see that in systems theory already. Systems theory, unfortunately, is not being represented in its full form in the academic field at the moment. But where applicable and practical it is, like system psychology, system biology, systems business and management, systems systemics in general and philosophy, through logic and linguistics and epistemology and ontology. And there are many more. But systems philosophy, as it really is in systems theory, have not yet been able to be established as a program and as a place of study. One can get a degree, which is difficulty for me, considering this is what I would plan on doing as a master's and PhD. Which is why I'm recording this audio, and also going to start writing my research paper now, is to get this out there and to try to get the ball rolling. So to stop here after 10 minutes of an introduction and try to get into the nitty-gritty through my notes. Now, these notes are literally in note form, that is to say they're not prepared, but I will go through it nonetheless. As I said, this is an audio recording to help log this information so that it can then either be worked upon, heard by others, and shared, etc. One of my basic concepts that I've created in this model is the concept that was revealed to me, which I call wave. The best way to understand this, the way it was revealed to me, was that, like an electron, the world, when observable, is there, and like the tree that falls in the forest that nobody hears but somehow falls nonetheless. But does it? That very tree, or that existence, when non-observable, that is to say, when you are not in existence any longer, somehow is no longer there. Or is it? And that might sound confusing and also simple and easy to deconstruct as a fallacy of a statement. But what I'm trying to reveal is this electron-like existence, that the electron, when observable, is there. But when not observed, that is, when not tested, is not actually there as a physical property. It somehow exists as this meta property that moves constantly. It never holds one position at a single time. That is to say that it practically doesn't exist, yet it is there and it affects. That, in and of itself, says something about our reality. That the things that make up the physical properties of all these things that we then can describe, like blue, or anything else of that sort, any property of this existence, is based on the idea that the very makeup, the physical makeup, is possibly not actually there, as it seems. But we know that all we have is the very existence and the very capabilities and sense data to analyze this material. So the best we can do is to then analyze it in a way that both assumes and says we know. That is to say, we treat it like a wave. We treat it like a particle, like an electron, both wave and particle. And the best way to do that, and why we do that in treating the data in that way, and this is one of the first steps that we need to understand to be able to collect the data and treat it properly. We don't want to create a binary tag that is simply just is super broken down, and I'm trying to remember the word for this, deconstructed. We don't want to over-deconstruct to the very simplest properties that cannot be deconstructed or digressed further or causally related to any property, like a universal property of color, which would then be something that we've already done. We need to be able to do that, but at the same time treat it in both a thing that is there and a thing that is interconnected. So what you do is you run each of these programs, both in its mechanistic form. So what we do is, when we collect the data and we deconstruct it to its properties and add each property as a tag. So if I were to describe a blue car, every single property that describes that blue car entity, that thing as it is, the entity blue car, is described and tagged for each and every single property that belongs to that entity, that living system. What that does is it breaks that whole holistic thing, that entity that we describe as one whole property, assumed to be all the properties that make it up, deconstructed to its particle form and treated as such, appropriately. What then, by creating an interconnected tagging system, that what that does is it then treats that data like a wave as well. Because when we run the system and we treat the data, both in its that whole entity is broken down in its particle form, and run it alongside all the other entities that are similar yet different, are not that entity, yet hold majority of the same properties that would hold for a blue car, say, as a red car. The simplest thing, the only thing being different possibly is the red car and the fact that it's not that entity, among possibly other properties, but the majority of properties holding the same for both. What then that does is it reveals the interconnected and the not interconnected relationships of the things. The things that are not interconnected are not negations, but simply the things that don't apply to the other property, or the other entity, I should say. So what that does is it still shows how it's interconnected, yet how it does not, it's not relative. It's not necessarily causal either, but it certainly affects it. And how is the question? We don't really know that answer. So that's one way to understand how and why this theory and model for artificially intelligible collecting the data in this way is important, and how it will impact the world. Because we will then be able to treat the world and understand the world through its current state of interconnectedness. What can happen is that once we've assembled at least one whole entity into its both deterministic and interconnectedness, we reveal things that, and solutions and problems that we never could have seen. That whole thing becomes a living system, a living entity. And because it lives in the model, in the artificial intelligence, we can do things that we would maybe ethically, or I mean, I'm not saying this has to be used for unethical things. What I mean is that there's crucial testing that can be done that we can't do today that would probably change the world forever, because it's unethical in terms of what it impacts in the environment. But if done not to the people or in the environment, would not be unethical and would change the world. I mean, these very simple, small examples. And I think that's also an argument not only for this model, but for any artificially intelligible system that does testing, because its ability to not actually affect the world, yet represent the world and test as if it was the real world. Sorry, just a second here. So, how do we then construct these systems of interconnected properties? What I've decided is that, or how I've understood it, is that because we're dealing with it, essentially what is a two-dimensional data collector, being the hard drive, how do we frame within that hard drive a two-dimensional framework of understanding the world? What I've developed is what I call concentration or categorical circles. These circles simply need to be touching the group of circles, meaning the whole, all of the circles that are connected, for it to then be interconnected to all the other things. The way that works is that when we want to construct something that is whole and all of its properties in it, we might imagine it as one whole proton, or one, not even something larger, say one whole. If you can think of the jungle gyms in a McDonald's or something, and where you have all these balls inside, and they're all somehow. I mean, you get the one stray one that's sitting up on the ledge or outside of the pool of the balls, but just concentrate on the idea that I'm trying to the metaphor of all these balls being put into a bin. So I have this bin, which is my hard drive, and I have this ball, which is this thing that I'm describing through its properties. So let's use the blue car again. So I have a blue ball that represents a blue car. I take that ball and I put it into the hard drive. I now have all of its properties. Now I take my red ball, which is going to have properties that are similar to the blue ball, being that it's a ball, and so is the blue ball. And they're both made probably of the same plastic, possibly different, but hold the very principle of what is this plastic ball made for this utility, being the jungle gym. Bit of a stretch, but hopefully you're following. I put this red ball into the bin, like the blue ball. Now I have two entities, which are broken down into this physical particle, and what I mean by that is its deconstructed properties. And I have these two put into one whole system where the interconnected properties are now connected. So it's a way of connecting these interconnected properties that are then described to each individual whole property. I once had the idea when I was trying to describe the wave function of interconnectedness inside the artificially intelligible design, and how I might actually be able to run it as a physical wave whole. And I'm not sure if that even has any meaning or value, and perhaps this was just me thinking through this whole thing in a metaphorical way at the beginning of my construction here in my notes. But perhaps, and I mention this just in case it might have value, that you run the data, both how it is in your mechanistic form and somehow in this possibly holographic or three-dimensional wave-like thing that represents all of these pieces of data that you've inputted like a wave somehow. And I'm not sure if that holds any value, but I mention it just in case it does. This is what I call the wave theory. So that's kind of just the name to throw it out there. So it should be noted, and I think somebody's told me this before, and I'm not 100% sure because I don't think I'm as educated in it as I should be, perhaps to get what I need to do done for this theory. But my idea is that I would love to see this used on a quantum computer, not only for its speed, but I think the functionality. I think inherently this theory requires one to run multiple algorithms on top of each other at the same time. Now, not necessarily, but I do know that fast computers, or very fast computers today, or supercomputers, could probably run this. But ideally, and I mention this just in case again, I think it would run cleaner and faster and more accurately on a quantum computer. Ways of running the model. One way of running the model, and I haven't actually deconstructed yet how the tag system works, and I'll get to that, which maybe you're waiting for, but I'll just run through this quick, is that what you do is that because this thing is functioning as the real world does, both in its fragmented mechanistic form and both in its wave-like form, you can ask it questions, and I think I mentioned that a little bit earlier, which is this way of running tests that you couldn't do in the real world. But I think that applies to a lot of questions that are already asked in the world. but are giving us results based on what I would suspect is our expectations, because we're inputting mechanistic data with intent and assumption. And I think that also possibly does affect how the system works, because the problem is that there's so much fallacy in data collecting to begin with certain companies polling and getting information, and who knows how accurate it is, and all this stuff. So, I mean, if we were to look back at census data from like 1860 and say that we could then take that data and put into the system, and it would truly reflect, well, I don't know about that. The problem is the human error. So I don't know exactly how one would get by that. But I do know that as far as keeping to properties of things and describing the world as it is will be the place to start. And I think that will then reveal ways of evolving this system and evolving this model that may be able to gap the human error and the human, fallacy of the winner writes history type thing, where, we can, even collect false data and from that get to some kind of truth. I don't know about that, but I throw that out there anyways. One other thing that is important in this model, in this theory, is using probabilities. I think it's important that when running the theory, that we input probability as well. And I think that because when we use probability and ways of probability theories today, we base it on consistent information, or information that has happened before, things that happened in the past that continue to happen today, and we know that as science. That is basically the grounding for a lot of what is called fact, which we know is not necessarily the case, but we have to assume, because it continually happens in a specific way, that gravity holds in a specific way. I mean, gravity not maybe the best example, considering we've not actually just understood it yet, but I think that's not relevant. I think the point that I'm trying to get at is that why we use probability in this model is that it's based on consistencies, things that have happened in a specific way in the past. With this model that will, I believe, fairly and more accurately represent the world as it is, with probability, I think we actually increase our ability to understand probability and increase our understanding of probability theories. I think with probability we begin to get closer to higher probability of things, and I think that's the point, is that once we understand both its fragmented and interconnected form, we can pretty well do anything. And I think that probability is either inherently within that to begin with, or that it will have to be inputted into the system as well. Staying on when running a model. When running a model, one way of understanding probabilities, and this is explaining further on, expanding on probabilities, is that what you do is you take a universal property such as color, and you run what I've constructed as calling progression lines. Color is universally singular. It is a thing as it is. It cannot be digressed to anything further. If something does not have color, it is not color, it is something else altogether and holds as nothing. It is either color or nothing, not colorless. It's nothing. There is no color. So that's why, obviously, this is why color holds as a universal property. So what we do when trying to understand the probabilities the amount of progression lines from color. And this may be a way to help collect data, I think, is to start with color. Then build on color into something in what I call a progression line. So what you have is blue as a foundation. And this is where I've constructed my three, what I believe to be three, and there's probably more types of properties, which are universal, base, and root. Universal property being color, and I've explained that. Blue being a foundation, by which blue is causally related to all the other colors, but blue is in and of itself blue, with other forms of blue and other shades of blue, etc. But blue as its whole, what is blue is blue. What then gets broken down further is what I call root properties that stem from foundations. The reason why blue is a foundation and not color does not, again, hold necessarily as a mechanistic thing that holds in some sort of position like an electron. It is both there and just not there in a way. It just is. So with the same with blue, we can reduce it to a foundation. We can know what blue is and reduce it to its foundation and say this is all the things that are blue and just move forward. And from there we can root properties out. We can seed from there, starting with variations of blue. So these progression lines begin with for universal properties, working their way out through foundational properties, through root properties, and further on. And I'm sure, and I have not yet been able to expand on this, and I'm sure I'm going to come up with the next level, which is probably going to be called like branch properties or flower properties or something, from the root, just to make it kind of nice and metaphorical and symbolistic. So what you do by being able to collect data through these progression lines is speed up your ability to actually collect all the data of a whole thing you're trying to understand without having to come into it or on top of it. Like you just are just going to collect the data by using these progression lines. You won't need to look for the information. The information will be collected through the artificial intelligence and the progression line. Next. Okay. So that's, I think, it for now. I think I've constructed everything right. No, the tags. Right, last thing, the tags. So each property holds a tag, say 001100111101. There's an infinite amount of zeros and ones in the combinations that you can make. So what that does for us is we can create individual tags that hold, say, 0010, and that 0010 we'll say is color, or we'll say 0110 to make it sound easier. 0110 tag binary code is color. 0110 dash dash. So what we want to do is build this language, this collection of data language and tagging system with different ways of breaking up the tags so that you know that that is that tag. So we would put two dashes, one dash before the 0110 and one dash after, which is like or dash in the opposite direction. So open, close, opening, tagged, closed, opening, tag, closed, opening, tag, closed. And so when you look at something, you can know all the properties through the binary language. So color being 0110 or open 0110 close will belong to everything that has color. That tag open 0110 close will belong to absolutely everything that has color. Anything that does not have color will not have it. That's how simple it is. You then create individual tags for every single property, working your way up from universals. So what we want to do is just start with a universal. create a progression line, and you work your way out. In the system tagging, the system will, in the beginning, be producing tags while you input data. So you'll write color, you'll categorize it as universal property, it'll produce a specific tag that will then be applicable to that. In the system, you'll then be able to say what this universal property belongs to through the properties that already describe the other things. Now, if we're doing a progression line from color, we won't need to make it causally related to anything at all. It'll simply begin with that, and you'll work your progression line outward. So you work from universal properties outwards to build the thing. So if you want to build blue car, you begin with color, and you begin with other universal tags to build what is a blue car. You then work your way out. You then apply probability and systems so that it's that holistic thing that is then put into one whole, say, blue ball, can then be put into a larger system where red ball exists in one system, where they can interact and be seen in their wave-like form, which is through their interconnectedness. So I think that's everything for now. In the future, I'll update it. Again, this audio recording is to help protect my intellectual property and to help get my ideas out there. My name is Kevin Savard. I live in Westmount, Quebec, or Montreal, easier. And today is January 5th, 2014. Or January 5th, 2014. And I hope you all have an awesome day. And thank you for listening.